and say OK, and it sent it, and boom, I'm hit. Now, that one isn't all that interesting because that's just a reflected attack. However, let's say I was the admin in this box. I wanted to go through my logs to see who all hit my website and who all was using what user agent, so I know how to manipulate my website so that more of my viewers can read it properly. Well, if I go to show log, let's say I'm an admin, and I'm going to say don't continue tampering. You see in the log, the script ran as well. So by putting an XSS into the user agent string, you might be able to get an admin later on when they go to view their logs. I actually have an entire website dedicated to odd XSS vulnerabilities. And let me see if I can go to that. Yes. By the way, I mentioned before, if you want to mangle SSS to bypass filters, take a look at hackers.org SSS HTML. It explains a lot of different ways to get around filters. The browser exploitation framework I mentioned before is at bindshell.net. The XSSMe Firefox plugin, which I actually haven't showed yet, but I will in a second. And the exotic injection vectors. The exotic injection vectors page is on my site, and essentially what it does is it talks about how you can do XSS sometimes via, well, let's say you have a tool that goes out and inventories all the machines on your network, and then it pops up, this is the machine name, this is the description. Well, if it doesn't filter out some of that data properly, that report, if it's an HTML formatted report, could possibly end up attacking you. And I go all into that in that particular article. I just realized there was one other thing I wanted to show, because I mentioned it here, but I don't actually, haven't actually shown it yet. All right, there's a tool, a tool for Firefox called XSSMe. If you want to quickly test, and I'm going to go ahead and reset everything to make everything go back to default. I'm going to add to this blog, and what I'm going to use is this tool called XSSMe. What XSSMe does is it opens up a little sidebar, and it allows you to, on whatever page you're at, quickly through all the forums try different injection vectors for XSS and see what bounces back and what actually works. Then it gives you a report. It's basically a really quick, simple way to scan for XSS vulnerabilities. No guarantee that it gets all of them, but it should get some of them. It actually is taking action. So from that standpoint, you may not want to do it. Now, the actions it's taking are in theory only annoying actions, something like the XSS pop-up I was showing before. It shouldn't be doing any kind of cookie stealing and so forth. But there is something to be said for not running that on a production box. If you have a side box that you're using before you roll something into production, test it at that point. And of course, after you run it, you probably have to go through your database and pull out stuff. And it's running through all that, and eventually it's going to return some information. To save time, I may end up canceling that, but eventually what it's going to do is pop up a report and tell me what seems to be vulnerable and what strings seem to work and what forms they were injected to that made them work. Unfortunately, it seems to be taking a little bit too long to run. All right, let's talk about fixes for XSS. Here's some of the things that OWASP recommends. First of all is input validation. If I wasn't allowed to put script in there or greater than less than, a lot of these attacks wouldn't happen. Now, just filtering those isn't enough, and I'll explain more in a bit, but proper input validation would have helped a whole lot. Strong output encoding. If you're using PHP, there's a function called HTML special characters that essentially re-encodes all those special characters as their HTML representation, so they're shown on the browser, but not interpreted as something you need to run, like tags. That's to specify output encoding to a degree. Apparently there's different ways depending on whether or not it's coming back as Unicode or a couple of different encoding types. Different things happen. So this recommends specifying output encoding. Also, they recommend do not use a blacklist, if you can help it at least. If you're trying to, I think it was Marcus Random who said don't enumerate badness. Instead of using a blacklist that says, well, don't let this in, don't let this in, don't let this in, do something that says, only allow this in. That has a tendency to be better, and you can easily do that on certain things. Like let's say you run a commerce site and you have certain part numbers. Well, if you know a part number is always 6 characters and it's always numbers, that's easy to filter for, and anything that doesn't match those criteria, you throw out. That'd be an example of a whitelist. Blacklists get a lot more complicated if you have rich input, like someone's running a blog site and there's all sorts of different tags they can put in. It gets a little bit more complex when you start saying, filter this tag, but let this tag in. One of the reasons just taking out script is not enough is because those weird ways that people try to get scripts passed. Some people in the past, to get rid of all XSS, have tried this. They've essentially gone through a website and all submitted data and say, anytime you see a less than script greater than, or a less than slash script greater than, remove it. Well, what some wise ass did was they put that in the middle, then they put the characters on either side to spell out the rest of the script. So whenever someone took out the middle, they actually completed the tag. And Snake on his website I mentioned before talks a lot about that. Also watch out for, I can't say this word, canonicalization errors. There's all sorts of different ways of encoding characters. What some people do is they do the stripping of bad characters first, then they canonicalize them after the fact before they represent them. The problem with doing that is if someone has represented characters in hexadecimal, but you try to strip them before, then as soon as they get interpreted in hexadecimal to their actual ASCII value, that's the point the injection actually happens. So the general recommendation, as I understand it, is to canonicalize first, then filter for strings. All right, the next thing we'll cover is injection flaws. Now, there's 2 main types of injection flaws I'm going to talk about, SQL and command. And here's a quick definition of injection flaws as OWASP states it. Injection flaws, particularly SQL injection, are common in web applications. Injection occurs when user-supplied data is sent to an interpreter as part of a command or query. The attacker's hostile data tricks the interpreter into executing unintended commands or changing data. And I'm going to give a couple of examples of that. I have a couple of apps in Mutillidae. One of them is the login form. And if you see that code at the top, that's essentially what the login form looks like. And what it's expecting in, that's basically the PHP code for it with the SQL code in it. Essentially what it does is it concatenates everything together to make the SQL statement it's going to use to check the database and find out if the person entered the right password. And that's the code for it. What it's expecting to get is, after it does all the concatenation, is this. It's expecting to see, and by the way, everything in red is the input that came from the user. Expecting to see the username equals something like Adrian, and the password equals some normal string. I also have a vulnerable application on Mutillidae that allows you to look up information on different domain names. I won't be able to do that here completely because we're not connected to the internet. But what it does is, in the background, it runs a command at the command prompt, nslookup, and looks up a website. That's the 2 intended uses. But let's say I got a little creative and injected something different. Let's say, for instance, instead of putting in a username and password like I was intending, like I'm supposed to, my mouse pointer has disappeared. That's disturbing. Let's say I was to enter something like the final 2 lines. If I entered in as the password, some password, single quotation mark, or 1 equals 1 dash dash space, it would modify the SQL statement to do something else. In this case, something or something, what does that equate to? That always equates to true. Or, sorry, something or 1 equals 1, it's always going to equate to true, because 1 always equals 1. That statement is going to always equate to true, and the way I have this particular database set up is it's going to log me in as the admin user, and I'll explain why in a second. Now, in the second case, let's say a command injection, instead of just submitting Irongeek.com to nslookup, what if I tacked on an and symbol, del star dot star on the end? What it's going to do is it's going to add on an extra command at the very end and execute it. I'm trying to remember what I would have to do. I believe if I use the pipe symbol or the colon symbol, I should be able to get other things execute if I was running this on a Linux environment. But for Windows, since that's what I'm using for this demo, you'd use the and symbol. Now, let's do a few simple examples of cross-site scripting. Of injection. By the way, this is that test I was talking about before. It reported back to me all the different strings that worked